bisector is vertex out. How many angles are congruent then? If I say that BD, ray, BD is an angle bisector of angle ABC, then two congruent angles are formed. Yep, and you're right, because now, vocabulary-wise, it means that those two are the same. What's the words? An angle bisector cuts an angle into two equal congruent things. It's a lot of words for the exact same thing as what a midpoint does. Angle bisectors, segment bisectors, midpoints, they all kind of mean the same. It just creates two congruent angles. So in this example, I wrote BD bisects angle ABC. I've already marked in the diagram itself which two angles wind up being congruent, but I just write out in words then. Angle ABD is congruent angle DBC. Okay. So the whole angle was 110 degrees, and it was a bisector. What does it make each angle? Well, what's half of 110? 55. Okay. That's right. It's all right. We'll get you mathing better. No worries. What's that? I know he did. I was trying to let it go so he didn't have to worry about it. But what if this whole angle was 90? What does it make both of these? Yeah. It's okay. Remember, we're still selling calculators. Gotta make sure you get one. I wasn't meaning to throw you under the bus, but don't forget a calculator. All right. They do, especially if they're made out of steel. Now, really what this works out to wind up being then, oops, we got a sequence here. If I jump right to the actual algebra, ladies and gentlemen, we have a lot of material to talk about here. If I say that in this diagram, basically the same thing, BD bisects the angle ABC, then you have some algebra thrown at you, which means that when I draw this, I know that I'm going to have two equal congruent angles. So, all I need to do then is BD bisects the whole thing. We get two congruent angles that are created. Well, the two congruent angles that are created are going to be angles ABD okay? That's what it says in the diagram. I know that has to happen because of the wording, which makes these two guys the same. So algebraically, I just have to write it out. What is ABD? What is DBC? That's all it is, man. So algebraically, it's getting you to do that. Remember, you did the exact same thing when they were segments. The only difference between an angle and a segment is that a segment's straight, an angle turns. It's the same process. Okay? And that's kind of what happens a lot in this first few sections, is that we're doing all the same math. That doesn't change at all. It's just a matter of understanding the vocabulary that's thrown in. Okay? So you have variables on both sides of the equation, 5x plus 2, 7x minus 6. Who are you going to move? The little guy. Good. So we subtract the 5x over. Now what? Add 6, very good. You're redeeming yourself from 90. And what's the value of x? 4. Notice the algebra isn't tough. It's just taking the geometry term and using the algebra. I think the instructions said to find both angles. Well, I know what x is. What do I do with it? Exactly. If I substitute back in here, and here, with any luck, we get the same number. If we don't, we go screw it up. So 5 times 4, 20 plus 2, 22. 7 times 4, subtract 6. You don't want to say that out loud in case you're wrong. 22 and 22 is? You're worried. Yeah. Are they the same numbers? Did we screw up? I don't remember exactly which angle you were supposed to find, but it's kind of what we're doing. Just read instructions. Not horribly scary bad, right? Okay. Take a minute and solve for these two. Okay. BD bisects is the bisector for either one of these angles. And figure out all the angles. Sure. Okay? Take a few minutes and do it. So we know that these two have to be the same. Variables on both sides of the equation, who are you going to pick on? All right, so we're going to move. You can argue with how you said it, but yes, you're right. So 3x minus 12 is 3. Add the 12, yep. Move everything away from your variable, guys. Remember, you're trying to isolate the variable, you want to get it by itself. Then what? And you get 5. Double check, make sure you didn't screw anything up. 8 times 5 is 40. 40 and 3 is 43. Good side there. So this side's 43. 11 times 5 is 55. Subtract the 12, we get another. On the other one, same idea. We know that they have to be equal because it says they are. We have congruent angles because the angle bisector. So you write it out. 5x plus the 13 is 9x minus the 23. Subtract the 5x over. You all right? It's calling on you. Okay, then I will tell my story. No, because she's gonna. No. No. It's all right. Add 23. You get 9 for the second one? All right. Which means you substitute back in, we get 45. 13 is 58. 81 minus 23 is also 58. And lo and behold, we're not too far off. Okay? Now remember, it's not always going to be given to you with diagrams. Sometimes you have to know how to draw stuff. Sometimes you have to be able to visualize it on your own. Example. What's that? Oh, this is nothing. It really isn't. Sometimes it gets really crazy. I'll have so much stuff up and running because I use it all the time. Now this one, you're given information. You're given information, you're given letters. We're told that you've got a ray US, and it bisects an angle. It bisects angle PR. How far is it on the measurement? Again, at least some talk about the little angle measure. To do that, what is this missing?
Oh yeah.
Have a problem that does not have a diagram, draw a diagram. It is so important to be able to do that. So QS bisects angle PQR, which means PQR. Does it have to be perfect? Just label it PQR. Now, a lot of times when I make angles, and I'm drawing them up because there's going to be a bisector and whatnot on there, I tend to make them larger than they need to be, so that way you can fill in the algebra of what they give you. That'll make sense here in a second. I know that QS is the bisector, and Q starts right there at the vertex. And I need to just kind of draw an ish to know that these two guys are going to be the same. I don't know what they equal, but I do now know that I can fill in the blanks. PQS, PQS, 3x. SQR, 5x minus 4. Do I know what the whole angle is? No. But do I know that those two are equal? I know that those two are equal in this example. If you want to throw something at them, it's fine. we don't know what the whole angle is, but I do know that each of those two chunks are equal to each other. So algebraically, set them equal to each other. Yep. I'm sorry if I'm not that fast at algebra, okay? Jeez. Oh. Subtract the 3x. This has come up a few times today. What's 3x minus 3x? 0. It's 0. It's fine. They do. And you know what happens is that people just freak out when they have nothing on one side. And that's fine. Because now what do I do with the negative 20? And you're right. X is 10. Okay. I believe I think it asked to figure out what angle PQR was. I just moved down so he has more space. So if X is 10, that gives me this side 30, this side 30, which makes the whole thing. Okay. Very, very common, straightforward stuff. Okay? Yep. 30. That's just one chunk of it. That's off. I don't know why I did. I should just put them on the online, but I did that too. What I want you to do, I want to walk you through the setup on one of them. I've had so many kids asking questions on this right off the bat. Yes. No. Just give me a minute and I'll tell you what's going on. All we're doing is just using one diagram for two problems. So my suggestion, because nothing I ever suggest makes any sense, would be to redraw just this. If you look at what angles you're just using the AOB, the BOC, and the AOC for that problem. So what I would do is this. I would just redraw that angle, those three angles, larger. A, O, B, B, O, C. Now, what you're asking is, guys, all I have done was taken this small written out thing and just made it bigger. Just drew it at a different scale. It doesn't matter. It doesn't have anything to do with this ray OD at all for this problem. The other problem 8 does. I was just saying, this problem has, these angles don't have the D in it, so I don't have to worry about it. So that's why it's irrelevant for us right now. Now, to what you're saying, oh, aren't those two angles equal? Does it say anywhere that those two angles are equal?
No.
Only.
Okay. So, we gotta add some
Thank you. And that's the idea here. I want you to draw something a little bit more visual so you can figure that out. Because it does not say anywhere that these things are equal. It doesn't say anything at all. What it says is that angle AOB is 4x minus 1. Angle BOC, 2x plus 15. And the whole thing is 8x plus 8. Remember, you can add two angles together when they share a common vertex and they share a common side to create a larger angle. So just like you said, you add the two small angles together and you set it equal to the larger. When you're doing these types of problems, it is imperative that you look at what they're giving you. It never said that it was equal. It doesn't say you have a bisector. It doesn't say anything like that at all. It's a matter of sometimes redrawing the diagram to help you visualize it better. Does that make sense? I've had so many questions on this first problem. Yes, no, maybe so? All right. Work on those 7 for tonight. We'll spend time talking about them again tomorrow. I'll have a good chunk of problems for review, which we'll probably be able to start within the first 10, 15 minutes in class. Meander about, do problems on the board, make sure we're getting this stuff done. And then we'll quiz and do our stuff, or do our quiz then on Friday. Okay? All right. We have time now to continue work.